ladies and gentlemen, the EV SmartCharge program is, one of Energy Queensland's main thing. It started in May 2020. Timing's everything. We heard Energy Queensland talk about their initiatives quite some time ago when we were up there, and they're really rolling along. They are right up there as leaders, but of course today we're in Victoria, so we'll praise them. And also it was great to hear Jet Charge and EV and FEMA and Green Road Loans just really kicking in here. Everyone's so excited about it. We want to talk about their Green Smart Charge program. Here's some of the early insights on driving and charging behaviours of participants involved in the program. Ladies and gentlemen, please welcome Robert Wilson, the Development Manager for Energy Queensland.
Lovely. Many thanks, John. And thank you, AEVA, for the opportunity to join us, or to join you for today. Hopefully you can all hear me, and I'll be sharing my screen with you. Just to quickly give you some relevance of who I am. I work in and represent the Ergon Energy Network and the Energex Network that supply a distributor for energy in Queensland. We're part of the Energy Queensland network, a larger organisation, but I just represent the networks here. So I'll share my screen now, and here we go. Hopefully it's the right one I'm showing you. There we go. So again, really appreciative of the opportunity to share with you. And also very great thanks to Laura and Jane, who actually done a little bit of setting the scene for us with regards to why the energy networks are potentially interested in looking at EVs and making sure that we're not going to be barriers to the uptake of EVs over time. Now, I think my webcam has turned off, but hopefully you can still see my screen. And we'll carry on. Okay, so as a network, we were just certainly interested in understanding how electric vehicles, the opportunities they may present, but also some of the issues they may present for us as well. So, and as described by Laura and Jane, the opportunity is that if all cars, EVs are going to be charging when air conditioners get turned on during summertime, then we're going to have some network issues. And we need to understand necessarily as a network what those opportunities and issues may be. So we really want to understand how we connect customer electric vehicles and how they influence the use of the networks in Queensland, and get to a point where we can optimise EV charging for both customers and the networks themselves. We needed to do some research around that, and so the opportunity presents itself, and what do we need to concentrate on? And really where we're finding that we had a real gap in our knowledge initially, and potentially for a while, was going to be in home charging. And why is that the case? Well, ultimately, we get to see a lot of applications for the fast and ultra-fast charging public stations. And so we generally not only get to see them, but also get to work with those suppliers who wanted to install those connections, an awful lot about what they're doing and the connection process, and then consequently we're very well equipped and knowledgeable about them. The problem generally works in the low voltage network, where we have very little visibility of what's going on past customers' meters in their home, and that is where the immediate largest impact of EV charging is going to be seen. And that may not be an individual customer basis, but as we've said, we've got a customer base that is the innovators and the technophiles. They're interested, and they generally congregate or live in the same areas as each other. So whether you have the opportunity and the wherewithal to purchase an EV, we are already finding that we are getting geographic clustering. And so that is generating some opportunity to understand when we start getting larger influx of EVs and connectivity, how we're going to cope with those clusterings. But also, we do get a little bit of information from our Transport and Main Roads organisation and government department that tells us to some extent where these EVs are, but it's only down to a suburb level. We need to get down to an individual household level. So these are some of the reasons we need to try and get to understand what's going on. So we decided that we needed to obviously set some objectives for ourselves, and that a short snapshot study wasn't necessarily going to be going to provide us what we were looking for. So we need to set up a 3-year minimum, a program whereby we can understand the change over time of how EV charging is necessarily impacting the network, and we need to get a reasonable cohort. So we looked to try to get 200 customers, to residential customers, to join our program. What were we going to test? What are the main things we wanted to see? Well, really, for a network, it was 2 to 3 things. It was to understand the difference between the vehicle types, so large and small battery electric vehicles, but also plug-in hybrids as well, and how the effect of those changes over time as customers become more adept with their cars, become more used to their vehicles and more confident in driving longer distances and maybe changing their charging behaviour. So we wanted to understand what was the frequency of home charging, what demand did that generate, and necessarily also what sort of energy usage was being required, on a per home basis. We also wanted to get a bit of an understanding of how the EV use, so the kilometres and trips, how that necessarily impacted the frequency of home charging as well. But also, not to be too myopic, to also get an understanding of necessarily what charging behaviour happened away from home as well, and how we might be able to use that and influence and inform the market. So those are great, but we also had some filters that we wanted to overlay on top of that. Is, certainly from a Queensland perspective, we've got lots of regional and rural customers, as well as southeast corner of Queensland. How does geography influence your driving behaviours and therefore your charging behaviours? We have an extremely large amount of penetration of rooftop solar. What are customers with solar and without solar? How does their EV charging behaviour change at home? We also need to get a bit of a handle on seasonality and peak days. How does summer and winter differ from each other? But then also necessarily we have our peak days, which are around Christmas time, around New Year's, but also Easter, public holidays, things like that. We need to get a grip and understanding of how EV charging really is influenced by those. Also want to understand necessarily what is the opportunity to influence charging behaviour, and Jane has and Laura have gone into some opportunities around how vehicle to grid, for example, may be an opportunity. It's not something that we're specifically looking at the moment, but we're very interested in understanding what value propositions may introduce the opportunities to influence charging behaviour, not least of which are the impacts of tariffs and the opportunities that they may present as well. All well and good getting data, but the problem is also we need to understand why customers are doing what they're doing. So during the research program, we need to undertake some attitudinal research as well with them to say, why do you do this, why do you do that, and can we actually match their attitudes up to their actual charging behaviour. So the outcomes that we're hoping to deliver would be, from an external perspective, is say, how can we share this information so that for customers and market players, be they the retailers, ourselves, aggregators of VPPs, whoever they may be, about what the optimal charging solution is that we could all take a handle on and make best use of. Start working with electrical contractors around when customers are talking about charges. How can we help them talk knowledgeably about charges to customers and the install requirements that they may be looking to undertake. And necessarily that last one, which is about interplay between public and private charging practices, what can this information do with regards to helping public charging providers, councils, whatever, with understanding necessarily the best places to install EV charging in a public forum. Internally, what it also is going to help to give us is around understanding of benchmarking data and the value propositions around good EV charging practice, and how can we necessarily encourage that and use that value. Does it mean anything with regards to changing our connection processes to improve the connection process for customers and give them more freedom about what they're doing without necessarily any network perverse outcomes? And then necessarily, and what Jane has alluded to and Laura have alluded to, what are the general energy management options that can optimize network and customer outcomes with value propositions, whether they're behavioral opportunities or direct energy management that gives customers some value, and what are those values and what are the incentives that can necessarily flow on from that. So we have set up our EV SmartCharge Queensland program. To deliver it, we had to find a partner that can can deliver the data for us, and so we've partnered up with a company in Canada called Fleet Karma, and they have done a couple of these programs in North America, and so they were relatively well placed to help us here in Australia. We needed to get a relatively good understanding what the models were that they could provide. Sorry, energy efficient here. I'll just turn the light back on. Apologies for that. And so there's a reasonable, there are 18 vehicles that are supplied within Australia that were supported by Fleet Karma. And that gives us a relatively good smattering across small EVs, BEVs, large BEVs, and plug-in hybrids as well. Our classification for a large BEV was anything with a 15 kilowatt hour battery or larger, and so subsequently a BEV small was anything with a smaller battery. The data that they can provide us in the particular offering that we took up around trip logs and charge logs is 15-minute interval data that we get supplied on a monthly basis. But you can see from there that there's an awful lot of information that the device that goes into the vehicle is just listening to what's going on in the onboard computer and just taking those snippets of information and sending them back through a 3G connection back to a data server, and that data server then aggregates that information for us. However, that data is all well and good, but we also had the opportunity when talking with our customers to join the program to say, can you give us some more info about yourselves? Because we want to understand from a Queensland perspective necessarily how these may influence your charging behaviour too. So we understand where the customer lives, the garage address, we know what type of dwelling it is because we believe that different housing will have different impacts, whether you have on-street or off-street parking, and whether there's a local charger for you. Obviously, all the details as best we can about the EV themselves, what tariffs the customers are connected to for charging, how have they connected, what is the physical electrical connection, not only the national metering identifier too, but who's the retailer, and necessarily do they have solar or a static battery storage at home as well. One big question, of course, is why would someone join the program? What's in it for them? Apart from a small $100 thank you or welcome to the program, the opportunity for them is to go through a portal and they can get data specifically downloaded for themselves around their charging activity, but also their trip activity as well. And based on what Jane said, it looks like a lot of people do their own tracking of their own driving and charging. Hopefully this takes a lot of the pain away of doing that and logging it yourself. So it's something nice for the customers to, or the participants to take away. So with using the data, this is how we are sort of trying to take as much as we can and draw as much information out of the actual raw data itself and the static data. So down the left-hand side, we can see that the Fleet Karma raw data, they present us with the utility dashboard, which has a certain number of filters for us that we're able to play with to understand and try and get down to some nuances. They have adopted the definitions that we've given for level 1, 2, 3, 4 charging, and you can see those definitions down in the left-hand corner. Generally, level 1 and level 2 are home charging, and level 3 and level 4 is public or ultra-fast charging and destination charging. So that gives us an element of the data that we can use. But then we have our static data, which we overlay and integrate with that raw data, and we then can add an awful lot more filters to that particular data to give us insights for our particular requirements here in Queensland. Get down to some real nitty-gritty. We have been running the program since May, but really the having managed to sort out some initial data issues, we're really now only 2 months, September and October data, where we've got a full cohort of customers on board and getting some really broad information and raw data that we can use. We have 193 participants as of the 24th of November, and the AEVA, through their promotional assistance, has helped get 30 participants to our program, so we're very grateful for that. From some of the static data, some of the self-declared responses that we've had is we have a really high penetration of solar PV. The average in the state is 30% of households have solar PV, so we've really tapped into EVs have certainly tapped into a very good market there from a solar perspective. We also have a very high penetration of battery energy storage customers, 18%. Probably no surprises. Most of our participants are based in the southeast corner of Queensland, but we do have 16% in our regional centres, so that's going to give us a reasonably good cohort to get data and understand what their differences in energy use and charging may be. 61% of large vehicles, probably no surprises that a lot of Teslas in there, and then the BEV smalls and the PHEVs make up the 39% of the rest of the vehicles. Over 50% have a dedicated charger at home, and 33% use your standard 10 or potentially a 15 amp plug. The rest will use public charging or charging from work. Almost 20% have greater than a single phase connection, and we've also been able to attract 28 commercial vehicles to the program, which is a bit of a surprise, or vehicles that said have a commercial use. So that's very interesting too, and it is already showing the fact that we can remove them or separate them from from the total data set. Some interesting nuances there to date to charging behaviours as well. We have 9 participants who are very lucky. They got 2 EVs, so I dare say they've ditched all their ICE vehicles and now fully EV families or homes, and 75% have just a general tariff, everyday 24-hour day, 7-day-a-week tariff, no particular pricing value propositions in there, and 10%, less than 10% are on economy or a night rate tariff. So that's some general data, statistical data from our static findings. Some nuances and some information from our early raw data findings is that 30% of all our participants do not charge beyond 90% state of charge. And some initial discussions would suggest that that is good advice that they're being given to prolong the battery life of their vehicle rather than charging at 100% every time they do. The charging at home behaviour that we're seeing is that 88% of charging events, that's events, not kilowatt hours, are level 1 or level 2. And at home, charging events are evenly split between level 1 and level 2 as well. 60% of the total charge energy is what's done at home. So 88% of charging events equates to 60% of the energy for charging EVs. 71% of away from home charging, surprisingly, is also done at level 1 or level 2. And we need to go and find out a little bit more about why that is the case. And 30% was at destination or, say, fast or ultra fast charging. But some of the sort of real headliner, I suppose, for us is that overall, on average, the daily charge requirement per day is 8.13 kilowatt hours, and that